which is a little bit confusing to get to. Carly said apparently they were in an elevator that didn't have a third floor. So you had to find the right elevator to get here. So I'm Matt Mitchell. I'm an assistant professor in forest resources management in LFS, and I'm also an IRES associate. And I'm really happy today to be able to introduce our speaker for this joint IRES and iBios talk, Dr. Carly Ziter from the University of Concordia in Montreal. So Carly is a friend. We went did grad school together in the same two labs at McGill quite a while ago. And it's really exciting to have her here to talk about the research that she's doing. So Carly, again, I said it already, is an associate professor at Concordia. She's also the Concordia University Research Chair in Urban Ecology and Sustainability, and she's affiliated with Concordia's Cluster for Smart, Sustainable, and Resilient Communities and Cities. So Carly conducts, I would say, solutions-oriented science, and I think this is probably from your website, to enhance biodiversity conservation and ecosystem service provision in urban and urbanizing landscapes. She researches a ton of different things. She looks at a variety of topics. I think she focuses more on questions rather than a specific urban ecosystem or a taxa. So she works on urban heat, soils, pollinators, birds, built environment design, environmental justice, community science, ecosystem service, urban resilience. I'm probably missing some as well. Not just you, but your lab too. So she also uses a wide variety of techniques and methods, from acoustic recorders and temperature sensors mounted to bikes to get around the city, to participatory research, and also co-developed research with urban communities. Carly's and her lab's work really focuses on applied work, and it often develops from partnerships and ideas from private landowners, community groups, and decision makers. And she's also an amazing science communicator. She really prioritizes some of that media work and outreach and innovative knowledge dissemination approaches. She handed around at an earlier meeting like a little zine that a student had made about choosing species for balcony gardens in Montreal and stuff like that. And she's won Concordia's Research Communicator of the Year award as well. So I'm really excited about your talk, Carly, and welcome.
Hey. Get myself mic'd up here for this side. For the folks on Zoom who can hopefully hear me, can you all hear me in the back? If I get quiet, like just give me a wave or something, and I'll try and project. But this room is not so big. So thank you, Matt, for a really lovely introduction, and it's been great to be here for the last couple of days and be able to meet with so many of you and hear about all this interesting research that you're doing here at UBC. As Matt mentioned, my research is broad and interdisciplinary. I often say that our lab is broad, and so these are my lab members hanging out up here, an absolutely fascinating and wonderful group. But we also urbanists, designers, engineers, entomologists, meteorologists, communication specialists, a wide range of colleagues and collaborators who have really shaped how I think about the city and how I approach doing kind of ecologically grounded research for urban systems. And we are also in partnership with an incredible community organization to allow us to do the work that we do, literally letting us into their yards and their lands. Often, I think when ecologists show this kind of map, we like to show it to kind of point out the dark spaces, the remaining wildernesses, and the spaces we need to protect, and how this light pollution is causing problems. It is. But these bright spaces, we're in the cities where we live, where we work, where we play. And the reason that this kind of urban ecology is so important to me is that we live in an increasingly urban world. Half of the world's people, 4 out of every 5 Canadians live. Means that cities are where people are encountering nature most often. And so scientists are increasingly thinking about where and how do we conserve nature for biodiversity, for human well-being in this increasingly urban world. When we look at this at a kind of global big picture, the stats are often a little dire, a little scary. If this is not planned, we anticipate urban growth equivalent to building, a new London, England every couple of months. These urban areas are often, kind of sprawling into natural areas and protected land, releasing carbon, damaging our delicate coastlines. But these challenges aren't just happening at, a global scale with these big numbers. They also occur across a range of scales where we have biodiversity change from, local extirpations through to the spread of invasives through trade. We see impact on ecosystem services from neighborhood urban heat islands through to effect on global carbon and nutrient cycling. And these challenges get a lot of attention. And I'm really glad that they get a lot of attention because they're important, they're big challenges. But I much prefer to spend time down here thinking about the opportunities. So how do we measure the positive impact of small scale habitat that we have left? How can we work more local participation, more participatory urban planning to support biodiversity? How do we use our urban ecology or our knowledge to support livability? And a lot of these solutions tend to skew local. If we want to work towards a more sustainable urban world, we really need to understand the ecology of our cities and our neighborhoods. So that's where we spend a lot of our time in my lab. We think a lot about the ecological fabric of a city. I've trained in landscape ecology, and so we take kind of a landscape approach to this. A lot about different habitats, large urban green spaces that are maybe the obvious parts of urban ecological fabric, through to designed green infrastructure, people's yards, street trees, vacant lots. If it's green, we like to go and measure it. And we ask, how can we better understand, often with an eye to management or policy, these spaces to both support other species and to influence our health and well-being? I have and will continue to throw around a lot of terminology as I'm speaking. And so just a little pause. When I talk about ecosystem services, I'm using this as a communication framework. There's a lot of terminology and semantics associated with this, where we might hear about nature's benefits, nature's contributions to people, nature's gifts, natural capital. But at the heart of all of this is attention to the way that we depend on our environments to live safer, healthier, richer lives. And a really important piece of concept to me is that these are co-produced. Ecosystem services don't just like magically flow from nature to us, particularly in the city. People are really involved in the management and production of these benefits or disservices. Biodiversity, I suspect that many of us in this room are very familiar with what this word means, but I bring this slide up mostly as a reminder to me to say that, working in the city, we are often approached by, officials, managers, groups that have the idea that biodiversity is good and they would like to have really thought about what that means. And there's a lot of misconceptions around this in the city, and we're going to circle back to that idea at the end of the talk. So broadly, if I had to kind of summarize what our lab thinks about and does in a slide, I'd say we think a lot about how the people who live in them, us, nature, and also how nature, us, make cities better to think about the needs of other species when we are making decisions. So we spend a lot of time in the lab thinking about how do we the various ecological benefits that we receive in the city, but also like who is implicated, who is involved in the management and co-creation of these services, who receives these services. And then we do a lot of what we might think of as more kind of traditional field ecology, conservation ecology about, how can we discuss practices, what kind of strategies or advice can we give to protect, the birds and the bees and the flowers and the trees in our cities. And I'm going to start, as Matt mentioned, we study a lot of taxa in the lab. I'm going to start with trees, ostensibly because trees play this really outsized role in shaping ecological fabric, but really just because they're my favorite. I've always loved trees. That's where a lot of my kind of ecological roots are. And trees provide a lot of benefits, but one that I seem to have stumbled into and can't quite get away from is the urban island effect. And the urban heat island effect, many of you have probably seen a figure like this. This describes the higher temperatures found in cities. So in the city, we pave over green space, we alter the energy budget relative to the surrounding areas. You don't need to understand biophysics and energy budgets to understand the urban heat island. Like stood in a parking lot, really hot summer day, feel that fading off. And often people are surprised. Well, you're in Montreal, we live in this winter city, but even in cold, snowy Montreal, where it is probably snowing right now, we have major challenges with urban. When, just a note, I'm gonna like front blaze my way through this presentation a little bit because I'm borrowing slides places. So, you know, maybe use that. So when I was growing up, Montreal would see about a week and a half of weather over 30 degrees each year. 30 degrees being a benchmark where particularly vulnerable populations really start to feel the impacts of urban heat. By the time I retire, I'll have about 55 days of the summer over 30 degrees. This is a really drastic increase, particularly in a city where most people do not have air conditioning. And the urban forest is one, the only, but one kind of lever we can pull when we are thinking about protecting our cities from heat in the future. So we've done a lot of work on urban heat, starting with my work as a graduate student, where I had what kind of thought, like, oh, I really want to understand these landscape, the urban heat landscape at a really fine spatial scale and look at heterogeneity, and like, I'm a cyclist. Maybe I could do this with my bike. We tried it. We threw some sensors on a bike. We built a weather station. I sampled day and night throughout a whole city of Madison, fine scale, vegetation and impervious cover. What you can see here is just, this is really, should put on a new slide. This is a route that I would ride through, and I'm going to color the line in there where you can see, you know, real time air temperature as we move through that landscape. We did a lot of number crunching that I'm happy to talk about behind the scenes. It's very tricky autocorrelated data. It's a pretty unconventional method, but to ask a pretty conventional question. What happens as you change canopy cover and impervious cover throughout an urban landscape? We did this at multiple scales, but I'm just going to show you some results from sort of neighborhood scale analysis, where, as we expect, you pave the That's pretty standard. That's often what we use when we measure urban heat amount of pavement. As you plant, a couple points that's jumped out to us from this analysis, the drop in temperature you can get if you get enough trees in there is as large or larger than the increase you'd expect from impervious. If we can green areas enough, we really can offset this local urban island effect. But at this kind of neighborhood scale, it was really strongly nonlinear. You need actually quite a lot of trees to stop these strong decreases in heat. When you publish a study about urban heat, what everybody wants to know is, where do the trees go? And from this data, pushing neighborhoods kind of over that threshold, getting into that more substantial cooling zone, is where you're going to get the most, you know, back in terms of trees. Planting isn't effective. Even at like a 10-meter scale, we measurable decrease in temperature. You know, planting one tree makes a difference, much as if you plant a tree and your neighbor plants a tree and the city plants a tree. But what really stood out to me is potential to use salt to overlook low canopy areas and really take this rich get richer approach to urban forestry. And that is a problem because we know that forests are, the patterns in our cities are so driven by these systemic biases in terms of who has access to greening and who doesn't. And so we want to use these kinds of results, you know, let's get every neighborhood we can up to these levels, rather than let's just focus on where we have the trees. And this echoes, you know, some other perspectives on urban forestry. So this comes from Cecil Knijndijk, who used to be here. And what I really appreciate about this as a landscape ecologist is that it's spatially explicit. We're not saying let's have a canopy target for the city. We're saying let's have canopy targets neighborhood by neighborhood to make sure people have, you know, access to those ecosystem services. I do not live in a 330, 300 world in Montreal. This is just a quick capture from a CBC article. And if you know the geography of Montreal, the town of the park extension, they are literally separated by fence. And there is a drastic difference in not only the canopy, but also the wealth of these two neighborhoods. And we see this city after city after city in Canada. So there's a nice article here where you could own postal code in and look at the patterns of greening and heat and wealth. And I did this first urban heat study right as I was finishing my PhD and moving into my new job. And I really spent a lot of time thinking about, what does it mean? What does it mean that I, as an ecologist, am the systems I'm studying, the patterns that I am like uncovering and making maps of are shaped by these incredible injustices. And how do I grapple with that going forward? Do I just say like, well, I'm just doing the science, or do I do something a little different? And as someone who felt incredibly privileged to be in this position of running a lab, of making community connections, of being kind of embedded in place, I decided that we were going to try and do a little different. Not all the time. We still do a lot of ecological studies on heat. We spend a lot of time without sensors and riding bicycles, but we now try and do some of that work in ways that integrates people into the work much more directly. So I'm going to do a few just real quick vignettes of some of the work my students are doing. Ling, who is very brave for doing a cross-advised biology, geography, and engineering, is she's modeling urban cooling capacity based on the composition and configuration of green space, but she's also matching that up with kind of vulnerability indices in this map based on age, very young and older residents who are much more susceptible to heat-related illness, and seeing that we see these strong mismatches of cooling services without very much kind of need, necessarily demand for those services, and other places where there is a lot of demand and a lack of supply. Bella was really interested in the kind of inequities that are often baked into our cities by legacies of kind of planning, environmental racism. And so she went out along with Michael, and they dug through archives and historical societies and all kinds of libraries, all in French, and found the historical legacies of parks, current day parks all across Montreal, and whether those used to be forested, for example, and remained parks, agriculture and transition to parks, or industrial. I don't have a current day picture here, but it's a park, like the parks. She asked whether the historical land use affect kind of forest structure and consequently capacity for services like cooling, and whether that would help to either like break or perpetuate inequities based on who was living in these areas. And just to show one of her results, perhaps, where she has the cooling capacity of contemporary urban parks with different historical legacies. And in the day, these are pretty similar. Similar capacity, about 1.5 degrees of cooling relative to the surrounding area. And this is, I think, a testament to really good current day management in a lot of these parks, really good efforts to have diverse and structurally diverse urban forests with the history of these places. But she does find that still at night in these formerly industrial spaces, which we know are areas where many more equity deserving communities live, we get significantly less cooling. So there's still a little bit of a hint of some of these inequities. But overall, it seems like if we can turn something into a park, we are capturing a lot of benefits, regardless of what that used to be. We're working now on an analysis of a lot of the soils from these spaces as well. Maybe closest to my heart, because I actually get to go in the field, which is pretty these days, is this producing ecological data with communities, where we have connected directly with communities, grassroots organizations that are advocating for conservation of green spaces, communities that know they are at risk of higher heat, more noise, worse air pollution. And we ask them, what do you want to know about these spaces? Where do you want to know it? Come up with indicators. One of the things they're interested in is heat. So we go up, we install temperature sensors together. This is a graph from former undergrad Evan. And, we see that these areas tend to be much cooler than surrounding, often very industrial areas. We can then use these results in, advocating for the protection or conservation of some of these spaces. But it also has led to some really interesting kind of new scientific directions as well. And so based on the locations that were selected by these community groups, we see, relative to a kind of city reference, all of these habitats tend to be quite a bit cooler, but we get really different temporal patterns. And so during the day, there we go, during the day, our forests are quite a bit cooler, and our open space, meadow, field tends to be, it's hot. Point this way, there we go. At night, even though the forests are still a little bit cooler, it's these open spaces that are really like the show. They're really cooling these areas off. And so it shows some of the value of protecting a diversity of habitats, and particularly undervalued habitat types. And we've used this as a springboard to then go out using better sensors, more replication, more areas to test some of these patterns, and they seem to hold across many areas of the city. This particular project was part of an interdisciplinary project with political scientists and specialists, where we'd also collect corresponding social data. We'd bring groups together to, do workshops, to do participatory research, to strategize together. And we have a new PhD student in our lab, Sarah, who is now kind of really taking on this project and working on topics around community mobilization and relational values, and trying to better understand the social ecological benefits of these kind of informal spaces in our city that are often really deeply valued by surrounding communities. So those are some of the ways we have thinking about measuring ecosystem services, temperature as an example in this case. And as always, one thing, it tends to open up a lot more questions, and a couple of the questions that have been like rattling around in my head since I finished my PhD are who? Like, if I, as a scientist, am saying you should have 40% tree cover, or you should particular configuration, or you should do, like, who is you? Am I talking to the city? Am I talking to who? So who's responsible for generating these benefits? And then also, how do we balance these benefits with densification in our cities? I'm not going to talk about that one today, but you can ask me later. So many cities are increasing canopy cover, including yours. And something that we think a lot about is the governance of these spaces in urban systems. So this is a nice neighborhood. It's hitting our 40 to 50% canopy cover target. Some of those are street trees that are managed by the city, but a lot of them are private trees that are in people's yards. And this is very typical that if 50% or more of our trees are privately managed, and we know almost nothing about them. If we look at the data we have for cities, this is our data in Montreal, pretty comprehensive. There's a lot of data there. Whoa, backwards. We zoom in. All the trees. This is true of your public tree data set too. You're missing all the backyard trees. So is every other city in Canada that has an urban forest citywide data set. And half a data set, like having half all the data in your system, it's like nothing to see that. And so we're really interested in like, is it? And Kaylee Taylor, who was a master's student, took this project on, where she was going to go like door to door and go into people's yards and measure their trees. And she was my first grad student, and she had her first committee meeting and got her sign off for fieldwork, and it was March 2020. And within a week, she was not allowed to go door to door and be the like Typhoon Mary of COVID and spread that throughout the neighborhood. And she, along with Maya, incredible Miller in communication studies, did a pivot and said the data will come up. And she science project. They made homeschooling to your kids out and measure trees and take photos and send us data. And about 100 residents in the neighborhood around our campus sent us their tree data. Ask this question, and Kaylee could graduate. They took pity on a student. And as restrictions eased, she was to go out and around campus, also along streets and parks and institutions. And what she found is that private yards on whole show much higher species richness than what we see in all of these other land cover types. And a large proportion, 30% of tree species, were only found on private land. There are other differences as well. So for example, if we look at which species are common, these are both maples, a Norway maple and a silver maple. Where on yards, the most common cedar, are a coniferous species. We don't see a lot of conifers, a lot of that functional group in our public tree data set. And so our forests might actually be a little more resilient than we think, which is great. Now we have a new student, Kenzie, back to these yards and look at bird behavior and diversity and kind of building on this neighborhood data set. Kaylee was also interested in the traits of these trees. And so she looked at what we call preference or service-based traits. So kind of analogous to functional traits, but based on characteristics that people appreciate. So things like flowering, color, or fruiting. And what she found, it's a little complicated ordination here, but if we look at street trees, these purple dots is a street segment. Each one is a yard, a little bit of similar size. And even though kind of one-to-one comparison, we'd see a similar species richness on a street segment and a yard, what we see about our street trees are very similar in their traits. We plant trees that are pretty tall with nice fall colors and grow pretty quickly, perform a very similar kind of role, whereas on our, in our parks and in our private yards, we span a much greater range of trait space. And so by including private trees in our inventories, we better understand the multifunctionality of spaces. And with that this is one neighborhood. It's a relatively wealthy neighborhood, a relatively old neighborhood around the university. Emma has now gone out to 25 spots across the island of Montreal, spanning a number of ecological and sociodemographic gradients, measured every tree, and is working her way through that data set of about 40,000 trees to ask some of these questions and see how generalizable these results are. And that's in collaboration with my colleague, Ellen. So we talked a little bit about how we assess benefits, how we try and kind of bring people into that picture and who's responsible for those benefits. For the last piece of the talk, I'm going to talk a little bit about how ecologists can play an important role as knowledge brokers to understand biodiversity conservation in our cities. I'm going to talk about pollinators, which is, I'm jumping on the train for urban pollinators. We're really having a moment right now across many cities, including Montreal. For a good reason. Urban green spaces can be a really important kind of refuge for pollinators. We have a lot of floral diversity, floral abundance in cities. People love to plant flowers. Maybe to pollinators. If we do things right, we should be able to protect pollinators. And this work is really led by Dr. Gail McInnes, who in my lab for a few years and now runs a pollinator conservation NGO alongside Serena Sino, who is doing her master's. So 98% of the credit here goes to Gail and Serena. And this work was inspired. Gail basically walked into my office soon after I started my job. I hear you know something about cities and you're here. I have a lot of experience with pollinators and I have a great idea of a project that we have to ask here in Montreal. And I said, okay, I'm intrigued. And it's an incredible baseline data set from our curator, Etienne Normandin, from 2013, 2012, 2013. And between 2013 and Gail walking into my office in 2019, Montreal had gone from 100 beehives. Etienne's original site are really along kind of a gradient of density of these hives. These are just few of the hives. This is one company that is hives that very quickly took their map away from the internet after we started using it. And Gail, I have no vendetta against honeybees. My in-laws are beekeepers. My husband grew up on an apiary, but I'm agriculture. And a lot of people that were installing these hives were doing it purportedly to save the bees and to support biodiversity. And Gail was concerned that there was actually competition for floral resources and wanted to see if she could go and collect some good data on this. So she, again, in 2020, bad luck for like the first ever field season of your lab. Gail went out with a team of researchers and they sampled across a subset of Etienne's original sites. We missed the early part of the season because of COVID restrictions, but we still got nice data set. We collected all kinds of, landscape variables, pollen data that I won't show today as another line of evidence for competition for floral resources. And this is the part of the talk where it will become obvious that I study trees and not bees. But we captured, many pollinator species, many were honeybees. 40% of the sample was honeybees, but also a number of other species, majority native species within our city. And we found, to start with just our 2020 surveys, wild bee richness declined significantly with increasing honeybee abundance. This is just number sampling period. And we actually that we were not going to find this trend. And the reason we that a lot of sites over here that are in areas with high honeybee abundances are gardens. The sites would expect the highest wild bee richness, known hotspots. A lot of the sites down here, which don't have a lot of honeybees because they don't want people getting stung while they're visiting their loved ones, but also don't have as many floral resources or floral diversity. So we knew they'd be low. So we thought like this will kind of straighten that trend out and we won't see this decline, but we still do. And it seems to be driven primarily by small bees. We also wanted another line of evidence. And so we thought, okay, we'll compare. We'll compare to the baseline data set. And this now is 2020 in honey here, like honeybees in 20. Increase in honeybees over that time period. Divergence of fewer bees and holds for both the total bee community and our smaller bees. So on their own, there are limitations with any of these lines of evidence. We only have a few years of sampling, but what we see is pretty convincing that urban beekeeping at high densities is likely impacting wild bee diversity. And this highlights a really important misconception around diversity conservation. Hive on your roof is not, in fact, going to solve the urban biodiversity problem. It might actually harm our native species. A lot of practical from this as well, like hives were. We could give much better advice and ask much better questions if that data was available. I don't like to end on kind of a bummer, and so if keeping not going to save the bees, what can and should we do? And Serena Sino has just had her master's work come out a couple of weeks ago at density of flowers, but also floral diversity, and particularly diversity of morphology, diversity of shapes of flowers is really important for influencing our diversity of wild bees. So trying to get at some of those mechanisms underlying floral and bee relationships. And Nicole is carrying some of this pollinator work forward by trying to develop a community science project where people will turn their balconies over to science for us to study plant pollinator relationships throughout Montreal. A question I often get when I give talks, when I introduce myself as like an applied ecologist or solutions-oriented ecologist, is like, does anyone use your work? Does anyone care that you've gone out and you've done all of this work? Sometimes this is an example of that was through the efforts of a local developer who went out and fundraised and made partnerships and consulted us in terms of what to plant, is now trying to develop research relationships with Concordia students to continue monitoring this site. This is an article, the rewilding program for the David Suzuki Foundation across Canada, on how he gave up his beehive personally after our research alongside the research of others. And this is the informal green spaces, the advocacy groups we work with, celebrating the protection of part of their space by the city of Montreal. There are also a lot of cases I could have put up here where we did a lot of work and it didn't really go anywhere. And so one of the things we're trying to do now is think about, what is that? What are the barriers when we're doing urban nature-based solutions work? And so recently, we, along with partners from Environment Canada, gathered together people from universities, national scale NGOs, cities, Indigenous partners to talk about barriers and opportunities for cross-sector collaboration. In this work, we had a super fun couple of brainstorming, prototyping idea, and now we have analyzing both a survey and that workshop to understand specific levers. And this is led by a few students who are using inductive thematic analysis to do this work. If, when I was a student measuring trees in Quebec with Matt, someone told me, you're going to be doing inductive thematic analysis of a participatory workshop, I would have said, what is that? And so it's a really cool example for me of how you grow in the job and you learn new things. So to wrap up, hopefully with a few minutes left for questions, Lessons from the city. Urban landscapes are really fun study systems to ask spatial temporal questions while engaging local communities in conservation. We need to protect what's left. Our remaining green spaces, our mature trees are working really hard for our health and well-being, and hopefully by measuring and provide better evidence-based recommendations for what we should protect and where, but we can't only do it in the park. We see so much importance of what is happening in private yards and street trees and community gardens to provide these services. And so taking that landscape or that mosaic perspective is really important, as is combating misconceptions. Cities are full of people who want to help, time and energy and money, and want to do something to feel agency in a scary world. And if we can kind of nudge them in the right direction, I think we have a lot of allies out there. But that also involves breaking down some silos and not, hiding in our office with our publications. And last, your actions are important. This is a system where, those small scale changes really do scale up to make a difference, even if all you have is a balcony. So I'll stop there. I am happy to answer questions now or later today, or you can find me in many places on the internet if you prefer that. But thank you very much for your time.
Statement. I forgot to do land acknowledgement at the start of the talk, so I worked around the traditional ancestral lands of the Musqueam people. And if you think we have some time for questions, I think the usual tradition in IRES is that students would ask the question.
It's a great tradition. Yeah. I don't know if you want me to field questions or you, or it's just, I'll repeat your question so the people on Zoom can hear it instead of passing around the mic. Go ahead.
Trees versus non-trees and maybe cities. I'm from Windsor.
Me too.
Oh,
Hometowns.
so yeah, one thing I noticed a big difference between Windsor and here is just the age of the trees. And so I'm wondering about cities that are maybe trying to do better and as a result of planting more trees is going to be good, but obviously there's going to take time for the effects to really
Absolutely
have an effect. So I'm wondering what should cities do in the meat? Are there any short-term solutions with the heat island effect? Because yeah, it's getting hotter and hotter, and there's heat dome effects here where people die because of stuff. So I'm just wondering, yeah.
Okay, so I'm going to try and paraphrase for the people on Zoom. We're talking about cities and tree planting and considering the age of trees and that it takes trees a really long time to grow and catch up, play into this situation, particularly with heat. The age, or really the size, but those are often the same, is super important for not just for heat, but for many of the benefits that we get from our trees. And tree planting, people love the idea of tree planting because it's very actionable. You can cut a ribbon and you can make a big statement about how many trees you planted. And tree planting is great. Tree protection is probably more important, particularly in the short term. And that is something that it's much less exciting to say we didn't compared to planted trees. A lot of cities are now implementing tree protection bylaws. You remove tree, particularly trees over a certain size, you need a permit. Those can be helpful depending who you ask, depending how well they're enforced. That's one thing we pay attention to protection. The other thing that I think is really, really, not just with trees, but with any sort of green infrastructure or nature-based solution, is that we plan and budget for long-term management and maintenance. Often we get really excited about putting something in, we got plant a bunch of things, and then they die a year or two later, and then we have these dead trees. That, first of all, is a waste of a lot of fun, spare money. It can also really backfire when you try to mobilize and excite people around the benefits of something. Those people think making sure that when we put projects in, we are putting the time and the budget in to maintain trees, to water, to prune those trees over the long term so that they stay healthy is really, really important. Short-term fix for heat. Trees are not the only solution, and we can't plant our way out of climate change, period. In cities or elsewhere. It's a part of the solution, but it's not enough. I mean, first of all, we obviously have to reduce emissions. There are other It's like making sure things available for people to go to during the day are people that have social ties much better in infrastructure, because you're looking out for your elderly neighbor, making a cooling center, there's a much smaller chance that they're going to get or die from that heat event. So there are social interventions. There are also things like cooling centers, engineering, changing our pavement to less heat absorbing materials, getting rid of pavement, tearing out pavement, particularly at night, is really, which is when heat is very dangerous for our health, is really important. So trees are a piece of it, but trees need to be planted in conjunction with a bunch of other strategies. Yes.
Trees on the private property.
Mhm.
However, there are also like and like for example invasive trees.
Yes.
Like they don't really control the spread of those trees, or they kind of spread out of their burns through either birds, dispersal, or like roots. So
that is a great question. So the question for those of you on Zoom or in other parts of the room is on, private trees are really important. They make up a lot of our landscape, but there's often nothing stopping someone from planting an invasive plant that's going to spread and cause damage to ecosystems. This is probably even more of a challenge with things like gardening plants, like ground cover and landscaping plants. If I could snap my fingers and make a change to the system, I would nurseries should not be allowed to sell us invasive plants. I don't know why they are allowed to do that. This is not my expertise. Given that they can, and people will buy things, I think there are a couple of ways to tackle this. One would be through trying to institute more regulations around, not allowing certain plants to be planted. Some places do have those regulations, again, whether they're followed. Another thing is education. I think more we can educate people around, making good choices about what they plant. Organizations in Montreal, we have a great organization called Sauverdi that works with private citizens to give them advice on what to plant, and they actually offer subsidized trees for people to select from, and they'll help you find the right tree for the place. I give a lot of public talks and do a lot of outreach with gardening groups and housing organizations and churches and everything else, where people will ask, what should I plant? What do I do? So I think the more we can educate people that there are better and worse choices. And also, this is something that is not limited to private land. If we look at trees in a lot of cities, this goes back to your question about tree age. We've made a lot of very poor choices unintentionally about what we plant in cities, where things grow really well, we plant a lot of them, and then we realize 10, 20, 30, 50 choice. We should not, Norway maple should not be the most common tree in Montreal. It outcompetes our sugar maple. And that's a really big challenge, because do you go in and remove those trees that are still providing other benefits like cooling, even if they're spreading? And so I don't have a great solution to how to make better choices about that in the future, other than more education into what we're planting in the first place to try and avoid some of those issues. There are some really good resources. The can't remember if it's the Ontario Invasive Species Council has these guides that are called either Grow Me Instead or Plant Me Instead. And they show like common landscaping plants that are invasive, and then they show you a native alternative that looks really similar. Really clever, because it's acknowledging that people choose things for very particular reasons. They're like, oh, you want something that is small and purple? Well, here's a small purple, well-spreading option for you that is better. And people tend to react a lot better to that if you acknowledge, we see what it is that you value and your preferences, and we can. This type of tree providing these type of benefits, here are good options for you. Okay, I don't know. You have two hands there. I don't use paper scissors for it. Mhm. Yeah, that's a good. So the question is about persistence of non-diverse species in cities, kind of consequences of, and I mean, often non-native species do really in cities. You just have a broader pool of species to choose from that might be able to thrive in the system. Like a city is a real hard place to grow up if you're a tree. It's salty, it's compacted, it's hot, there's like roots underground. Like it's not a super like conducive environment. And so we are a little bit more limited in terms of I don't plant city trees. Arborists and groups who are planting trees are a little bit more limited in some of their choices, and often some of the trees that we've found do really well might not necessarily be native. And there's also considerations around, cities are very planting trees from slightly of the range that will do better in the long term. I necessarily like my ecology card revoked. I don't necessarily think it's a problem that all of our trees are not native trees. I think we need to think fully about particularly producing too many of the same tree in our cities, right? That's where we've seen a lot of really big problems in cities. Things like in Montreal, where 20% of our public trees were ash and emerald ash borer. Instead, we're going to lose 1 in 5 trees, including sometimes like of trees. If you walk through Saskatoon, Winnipeg, these beautiful forests, Dutch elm disease is a real threat to that canopy. So we rely heavily on a particular species, whether it's because it's a really good, it's a cheaper species or whatever it is. We don't have a lot of resilience built into that system. We really risk is in our urban forests very quickly. Diversifying is very important, and it's something that typically cities are doing much, much better at now. It's just there's a legacy. It takes a long time for those trees to grow up. But I know we don't want to be planting invasive trees in our cities. Also, we don't necessarily limit ourselves only to the native species. And there's no guarantee that your species is going to survive and thrive. Ash is a great tolerant native species that provides a lot of benefits, and a lot of cities are dealing with very serious consequences now because of planting so many of them. You had a hand here, and then we're going to go over there. Yeah, me too. Mm-hmm.
Or like more native folks nicer, I guess. So I'm wondering like how we should distribute our working towards like just kind of letting things grow how they're growing versus like the store.
Yeah, so the question is on vacant lot ecology, but I think it's broader than that as well in terms of should we kind of let nature do its thing and naturally, or should we intervene? What are the consequences of that? That's a great question, and that's something we're seeing in Montreal right now. The city has a policy of gestion différenciée, which has like a really bad English translation. That's something like differentiated mowing, and they let things come back in the seed bank. Biodiversity gets that can often be biodiversity in a space, depending a little on what seed bank. There are issues where things come up and spread. But one of the big challenges with that approach is actually social. People tend to get really upset because they hate it, because it's messy. Again, to partly education, and partly I think there are a lot of ways other than just like letting it, you mow a nice neat border around it and you put a little fence, or you put a little sign that is like biodiversity zone, or supporting the bee, whatever it is. Those small cues that show one that this is intentional and this is cared for, and or abandonment can often be really important for changing people's perceptions about those is. There's the whole kind of literature on this. If you look up Joan Nasser's work and Cues to Care, she has a lot of great work on, very beautifully written work on this. And I honestly, I think we need to study more. I think we need more research. We're going out and actually measuring like what is coming back in the seed bank and which is that supporting, and are there maybe intermediate strategies as well where we like put a seed over an area and let it grow, but we're not going like carefully tending every single plant in an area, which takes a lot of resources. But there's two sides. There's ecologically, what's in the seed bank, what plants are coming back, and who are they supporting in the ecosystem. But then there's also, what neighbors think, and are they okay with this? There's a big kind of movement now in urban ecology and landscape architecture, trying to push back on naturalized. Your grass has to be a certain length. Say a naturalized front yard, your neighbors can call the bylaw police on you and say that. There are these like distinctions where, like, hey, if it's a garden, but what is considered a garden? It's about perception, right? And so there's a lot of work on just kind of changing culture and pushing back on some of these bylaws. And there's a lot of social scientists doing great work on this as well. Like, when does the kind of social norm of neighborhood shift? I used to live in Madison. It's common to have like a front yard prairie. Prairies and other neighborhoods, grass. And there seems kind of a time enough people do it that it to do. Yes.
This question segues really well from the last one.
Great. Thank you.
I was curious about, so I think we've seen sort of a trend towards people getting excited about pollinator meadows and these types of features, but it seems still like leaf litter and deadfall and some of these sort of like uglier characteristics are harder to foster to the public interest in. And as a science communicator, do you see windows of opportunity for trying to support those that variability? And also, do you see certain taxa that really suffer from
so the question is about what kind of wildness like, and whether there are some taxa are easier to motivate people to make change about than others. And my graduate student who this a lot because she studies things like spiders and grasshoppers and also butterflies are them, and like, okay, like, what are you doing? Why are you doing that? And it's like, these are your friends eating the things you don't want. Like, these are excellent critters that have around. People are like, no, thank you. We do not want them. So there are some species hill battle, get someone here. I think there are, one strategy is finding the species that people do like and care about, that you can some things like, the leaf litter. So something that we often have success with is people love fireflies. Fireflies remind them of magical summer day out in the county, like seeing a fire. Just this, like, it's just, and if you tell people like, well, fireflies are where the leaf litter is, or like Luna moths, or, if you can point to species that people like and want to protect and say, this is their habitat, this is their home, they need to complete that. They are more likely to then come around to like, well, okay, maybe it's not so bad. I think also that we try and meet people where they are, and that we help people take small steps. Like, if you come in and you say, well, you have to, tear out all your grass and plant a pollinator garden and do things in this way, like, that's a big and overwhelming change to try and ask, not to mention like a difficult and expensive change to try and ask someone to make. But if you can say, hey, you could leave your leaf litter like in your garden bed as mulch, and that will protect these certain species. Or, oh, what if you just swapped out a little bit of your lawn or planted a few of these things? Often then people see these changes. They see butterflies into their yard, or they see flowers, and they get interested, and they see birds. And then they'll start making more and more changes. tend to be fairly influenced by young people in their lives, whether it's kids or neighbors or whoever. So I think environmental education at a younger level. There's a great study, and I can't remember who wrote it, on climate change advocacy and how men are most likely to be influenced by their daughters to make a change. There's this clear link where I think if we can start education and start some of those shifts younger, so it does kind of trickle up to other levels. But yeah, the like the creepy crawlies and the leaf litter and the things people don't, they're try and find a way to explain why that is important, or you try and link it to something that people do want and like, and something that they are more kind of emotionally tied to. Yes. Great. Mhm.
In particular, there was one result that you had where I think you said that individual trees do not have as big of an
Mhm.
impact of
Mhm.
cancer. And I'm just interested in how I think different people have found different results.
Yeah.
And that one or some other people who have been specifically, we saw this paper about trees having a bigger impact on cooling and arid cities.
Mhm.
And so to me, that would mean that we should have a bigger impact in neighborhoods with higher cancer, with lower cancer cover. And so I'm wondering, I don't know, if you have any thoughts on how you reconcile that result.
Yeah, absolutely. So the question is about reconciling results from different studies from different cities that sometimes feel conflicting in terms of trees and temperature. And that is something, so I'm gonna pull up, that's a full set of results. And so across different scales. And so we do see, like, even in a 10-meter radius, like we see a measurable cooling from what, like 1 tree. But as we get to whole neighborhood scale, that's when we really see the stronger effect. In terms of different types of cities and arid cities, I think that, yes, that's true. And we've seen that in a few studies, that different types of cities are going to be, trees are going to have a larger or a smaller impact. Particularly, there's also differences in like the day versus night cooling as well that are often really closely related to things like humidity and transpiration contributing to that. What I think we really need in urban ecology in general is a lot more cross-city research that's using comparable methods. Right now, we see a lot of results happening at the scale of a particular city, and it's really difficult to generalize to, like, okay, is this a Montreal thing or a temperate city thing or a humidity thing or a density thing? And really what I would love to see is more kind of replicated research where we try and create similar study designs across multiple cities and see, how many of these things are generalizable versus city specific. Some of my students are working on that now with things like citizen science data or public tree inventories to just do comparisons across multiple cities, across things like climatic gradients or city size gradients, because we do see that often results will hold in a particular context and not in another. And even things like the urban form and built environment. Like in Madison, where this research took place, it's a relatively low density city. We don't have a lot of tall buildings that also are going to play a role in terms of changing patterns of wind flow, casting shade, changing the relationship of those trees. And so repeating this in areas with different urban forms and seeing if these trends still hold is also really important. And I think in terms of kind of reconciling these results, one thing that I think is really important, that when we are making decisions, when we're changing policy, when we're advocating, like, we probably shouldn't do that based on just one study, right? And we don't usually, right? Each study provides a little puzzle piece or a little building block. We might make decisions in that particular city based on those results, but when we're trying to do broader decision making, we need, multiple studies, multiple replicates to be confident that we're moving in the right direction. So I would say I would love to repeat this work across multiple different cities, have a little army of bicycles out there and see what we find. Good question.
I think we're on top, but I think I might have got burning questions. We'll probably answer after this, but I just want to thank you, Patty, for a fascinating talk. And I think I promised like a wide-ranging talk and discussion. I think we got that.
Yeah, and you can find me in all these places. Thank you very much.